Alright, so today we are covering Quicksort, and I thought I'd start off with showing sort of the strategy for Quicksort before we dive into the individual parts of it. So Quicksort works on a divide and conquer tactic, where you chop the work that you're going to do up into halves and then recursively do the same work for each half. So what you do is you pick a pivot point, and there are many different ways you can do that, but the one that we're going for, we're going to pick the last element, and I'll explain that more later on. But as you do, you pick that pivot point, and then you get so here we chose the last one, and then we rearrange all the data in the array so that all the elements in here are sorted in a way so that the values that are smaller than the pivot point are to the left of the pivot point, and the ones that are bigger are to the right. So as we step through here, we've done our first partitioning. We now have 3 and 1 on the left side, and then 5 and 9 on the right side. And then we continue by doing this the quicksort again, but on the left side and on the right side. And we keep on doing that until there's nothing left to do, until there's only one element sort of in this thing. And that is the strategy of the quicksort. And now I'm going to go on to show you how the partition works, and I'm going to do that with a picture and an example instead than of looking at the code, because I think it is more helpful. Right, so I'm going to try to explain a part of the quicksort algorithm, which I think is the hardest part to understand, which is the partition scheme. So the partition scheme that I'm going to cover is called the Lomoto partition scheme, and I think it is the one that you will probably stumble upon most if you're like looking at other implementations of Quicksort on the internet. So let's start with an example to illustrate how it works, because I think that's easier than just looking at the code. So we'll start off with a unsorted vector here. 5, 4. Okay, so here we have a vector that we start off with that is not sorted. So what we do is we choose a pivot point, which in this case is going to be this guy. So for this implementation that I'm doing, it's crucial that you choose the last element as the pivot point. And that will become obvious later as we walk through this. So after we choose the pivot point here, we're going to define a range that we're going to use for a loop. So that loop is going to start here and it's going to end here. So we'll kind of work on this here section. So we're going to iterate through that, and we're also going to use a sliding window, which is just an integer value of an index that we're keeping track of. So when we start off here, we start at this position here, which in this case is going to be -1, because this is 0, right? So the sliding window starts at -1. And when we're going through this loop, what we're going to want to do is we're going to look at each element and we're going to compare it to the pivot point. And then we're going to see if it is smaller than the pivot point. And if that is true, we're going to move this sliding window one step forward, and then we're going to swap the values that is in the sliding window with the one that we're currently iterating through this loop. So let's take a look first at one step of this iteration. Type this guy out again. Oh, it's the same. Okay. Put one over here so I can use it later. All right. So, okay. The first thing we're going to note is that 5 is not smaller than the pivot point here. But so then we don't do anything. But 3 here, this one is smaller than the pivot point. So what we're going to do then is we're going to take this the sliding window. So it was at -1, right? Now we're going to move it up to here, and then we're going to swap these two values. So 5 and 3 changes place. So let's just see what that looks like. Type it out. 9, 1, 4. Okay. So as you can see, these two have now swapped, and the sliding window is here. So what you can sort of maybe understand here is that everything, when we're stepping through here, that is smaller than the pivot point is going to be at or before this sliding window here. So you see that as we step through here, the sliding window moves along here whenever we swap something. So we get all these values on this side here that are smaller than the pivot point. And I think that kind of helps to understand what's going on, because at the end we're going to do one final operation. But let's step through the whole loop here that we started doing. Okay, so for the next step then, we're going to step, so now we're at this position here. Step over to the 9, which is not smaller than the pivot point, so we don't do anything. But then we reach the 1 here, which is smaller than the pivot point. So now we're looking at this guy, and we got our sliding position, which was at this position now. So okay, so that what happens now is, of course, we move this one step forward again, and then we swap these two values. So what we end up with then is 3, 1, 9, 5, 4. Yeah. Oops. So this bracket's supposed to be the same here, I just typed it wrong. But yeah, never mind that. Okay, so now we reach the end of this range, and we still have the sliding window here. We're going to do the final step here, which is that we're going to move this the sliding window one step forward again to this position, and then we're going to swap the pivot point here, this value, is going to be swapped with this one. So what we then end up with is having 3, 1, 4, 5, 9. So now you can see that this array is now sorted in the sort of the definition of what this partition scheme is supposed to do, which is take in an array and rearrange it so that in this array all the elements that are smaller than the pivot point are on the left side. So we got those here, 3 and 1. They're smaller and they have been rearranged so that they're behind the pivot point of 4. And all the ones that are larger are to the right of the pivot point. And you can kind of, when you look at this, understand that that's what's going to happen, since we use this sliding window and we're always comparing the elements here to the pivot point and then moving them along to the left side here, and then at the end we simply swap whatever is at the next position for this sliding window with the pivot point. So of course this array is not completely sorted yet, but that's what the sort of the rest of the algorithm is going to take care of for us, and that's the partition part. So what ends up happening now is that we return a new pivot index. So here we chose this one, but now we're going to choose something else, and that is decided by this sliding window here. So when we return from this partition scheme, we're going to return this sliding window here, the index, not the value, but the index here. So it will be 0, 1, 2. So the pivot index that we will get out will be 2. And we'll look more at that when we look at the Quicksort algorithm. But I thought I'd start off with showing this because it makes it easier to understand it. All right, so after going through the partition scheme and how that works, I think we're ready to start looking at some code. So I have here a driver code, sort of, that takes an array and then performs the sort, the Quicksort. So we're using the same one as I described in the partition scheme, 53914. And we're going to send that into our Quicksort function here. Check some recording. Yes, I am. We're going to send that into our Quicksort function here. So I've written here sort of the strategy of the Quicksort, which is to first pick a pivot point, and then we perform the partition and sort the array according to that. And then we recursively sort the left and the right side. So underneath here is the example written out. So if you were to look at this yourself, you can see each call here to the Quicksort, some of the interesting values that are coming out, like from the partition and sort function, and the entire call graph for this one, because it can be a bit tricky to understand. So I thought this was quite helpful. I've written the same sort of like run through of all the calls to partition and sort down by the partition and sort function as well. Okay, enough of that, and on to the actual Quicksort here. So first of all, we perform a check. So start is smaller than end. That's the sort of the base case for our recursion. It means that we should stop trying to sort more. And then what we do, so we're going to pick a pivot point, right? And we're going to let this partition and sort function do that for us. So for our first call, of course, we're starting off with the whole array, which in this case it's an array of size 5. So we have start at 0 and end at 4, because that's the last index in there. So we're going to step into partition and sort, which picks the pivot point as the last one. And here I've written a little comment about that, but for this particular implementation, it is crucial that you do choose the last one, otherwise the rest of this code is not going to work. And then we do, as I explained before, we choose a sliding window here, which is start -1. And then we step through the vector here, using the start and the end indexes here for the loop, and we check if the value we're currently at is smaller than the pivot point. If so, we move that sliding window to the right, and then we swap the sliding window with the value that we're currently at. And then at the end, we always, you can see this as that you're moving the sliding window 1 position forward here. We're always using sliding position +1 here. And yeah, we simply swap that and we return the sliding window +1. So that's what we get back. We moved it forward and then we returned it to the quicksort. So we're going to come back here. We're going to get some pivot value. If it was a vector of size 5, the pivot point is, for this case here, this input, where we're going to get pivot point at 2. And then we continue with sorting the left side and the right side. So that's the algorithm. And I think I'm going to try to run through this case that I have here in the debugger. And I'm going to show a picture to sort of illustrate what's going on. So let's start the debugger first. Okay, so if we step in here, we can see that we start off here 53914. Start is 0 and end is 4. So I have a picture here. So the first step to quicksort is this one, and these boxes indicate the calls to the partition function, partition and sort. So we're going to make 3 calls to them, and this is the order. So first we're going to make this call, and then we're going to do it on the left side, and we're going to do it on the right side. And I've marked here when we actually do a swap. So we can see here, okay, before it was 5, 3, so these two have been swapped to 3 and 5. And before you can see here, so it was 5 and 1, and we swapped them. So now it's 1 and they've been swapped here. And then we have the last step that we do. We swap the pivot with the sliding window that is now at this position. I think I will mention this already, because when you look at this code, something I thought it could be a bit confusing and it's not maybe obvious is that sometimes you're going to end up swapping, making a swap that's not really a swap. It doesn't really do anything. So here, in this case, we swapped 5 with itself. So that's really doing nothing. And then at the end, we swapped 9 with 9. So that's something that is good to be aware of if you're looking at a function and you're scratching your head. Like, well, what's going on here? Wouldn't this swap some values that I don't? Sometimes this is what's going to happen. And yeah, we'll see that when we run through the code. So, okay, back to the code. Here we're going to make our first call into the partition and sort, which is this one here. And these are all the steps that we're going to do. So we kind of looked at them already, but let's just go through it anyway. So we choose the pivot here, which has the value of 4, which is the last element in the list. And then we have this the sliding window here, which you set to -1. And then we simply walk through here. So the first one we're looking at is 5 is not smaller than 4. We do nothing. Okay, 3 is smaller than 4. So we're going to move the sliding window forward. So now we're at this position. And we're going to swap this one with the one that we're currently at, which is this one. So these two values will get swapped here. All right, so we can see that that happened. 3 and 5, 9, 1, 4. Okay, so now we're currently at 1. We're going to increase here, so we're now at 2. 9 is not smaller than 4. We do nothing. And now we're at 3. So 1 is smaller than 4, which means we're going to move the sliding window 1 step forward. And so now we're at this position. So we're going to swap 5 and 1 here. All right, perfect. So now we got 3, 1, 9, 5, 4. And since now we're going to exit this loop, right? And we're going to perform the last step, which is we can consider it as we're moving the sliding window 1 position forward. So the sliding window is at, what was it? Here. So 9 and the end, and this is where it's important that we chose the end one here as well. So we swap the 9 and the 4 here, and we end up with this array here. Can I see it better? 3, 1, 4, 5, 9. And now we're also going to return a new pivot index, and that's going to be 2. So it's here. Right, so I've written this out here. The pivot is here is 2. Okay, and now we have the sorted one here, 3, 1, 4, 5, 9. The first sort has been performed around the value of 4. And now we're going to sort the left side, which is starting at 0 and the pivot index -1. So we'll be looking at this half here. So let's have a look at this one here again. So this is the second call we're making. So we can see here what's going to happen already. We're going to make this swap here, but let's look at it in the code as well. Okay, so now our start is 0 and the end is 1. So we're looking at that section, and we're going to perform the partition and sort on that section of the vector. So the pivot value is going to be 1. All right. So the loop is going to do nothing for us because 3 is not bigger. 3 is not smaller than 1. So we don't do anything. But in the end, we're going to move the sliding window, which is, since start was 0, it was at -1. We move it 1 step forward. We will be at position 0 in the vector, and we'll swap the 3 and the 1. All right. And then we're going to get a new, because this part doesn't know the size of the vector, right? It's going to give us some new pivot point here, which is going to be 0. So the pivot here is 0. And this will spawn a couple of quicksort calls that will not do anything because we have this base case here where the recursion is going to end. So 0 and -1, okay. So start is now isn't smaller than end anymore. So we don't do anything. And the same thing is going to happen here. So we're going to come in with 1 and 1. So start is 1, end is 1. Now 1 is not smaller than 1, it's equal. So we don't do anything there either. So all that we have left to do is from the first call here we made, we're going to sort the right side. And we can see that one here. What's going to happen here is, so at this point the array is already sorted, and so nothing's really going to happen for us here. We're going to make a couple of swaps that don't change anything because we are swapping with ourselves. Let's look at it though. So we have 2 plus 1, which is 3, and then the end 4. So now we're okay here. We're going to do the partition for this part. So the pivot here value is 9. So it's the last element in this part of the array that we're looking at. And our starting position is 3, so our sliding window will be at 2. Yeah, so the sliding window is there. And then we're going to start to look, okay, so 5 is smaller than 9. So this is going to be true. So what we're going to do is we're going to move the sliding window from position 2 one step forward. So now the sliding window is at position 3, which also happens to be the position that we are in the loop. So we just end up swapping 3 with 3. So nothing happens here, except that the sliding window has been moved forward. So the sliding window is now at 3. And then we do this last step here, which is, okay, we move the sliding window one step forward. So now it's at 4. And then we swap what's at the sliding window, position 4, with the last element, which is also 4. So nothing happens here. The array is unchanged. And then we get back a new pivot index, which is at 4. So see here, 4, right? Yeah, I think I wrote the wrong one here. It ought to be 4 here. Oh, okay. So we will make another couple of quicksort calls that are going to end up doing nothing. So 3 and 4 minus 1, which is also 3. So start and end are the same here. So we do nothing. And then again, we have 4 minus 1, that's 3, and 4. So let's see what happens here. Oh, sorry, 5, of course. So in the last one, can we step back and see the pivot value here? Yeah, 4 was the one that we got here. So 4 plus 1 is 5, and end is 4. So we're coming in with 5 and 4, which of course will mean that we won't do anything. And that was it. Now the array is sorted. And yeah, this was quite tricky for me to wrap my head around. I had to look at this many times. But I hope that this video maybe helps someone else to understand and grasp this algorithm a bit quicker than it was for me. So thank you very much for watching, and goodbye.